Hello everyone, I welcome you all in this lecture. So in today's lecture we are going to learn about the diagonal scale. Okay, so first of all let me tell you why we use diagonal scale. Okay, so whenever we need to represent the relationship between three consecutive units, okay, or a division, it's or a major division, minor division and its subdivision, then we have to use the diagonal scale. So it is used to represent relationship between three consecutive units. Okay, or a unit, its division and its subdivision. For example, let us say we have like units mm, the unit of distance mm, then centimeter, then decimeter, okay, then meter, then decameter, then hectometer, after that kilometer. So anytime if I want to represent the relationship between any three consecutive units, for example between kilometer, hectometer and decameter, these are the three consecutive units. Similarly decameter, meter, decimeter, these are the three consecutive units. Similarly decimeter, centimeter, millimeter, these are the three consecutive units. So whenever we need to represent the relationship between three consecutive units, then we use diagonal scale. So this covers the first, when we say the three consecutive units. The second part is units, its division and its subdivision. For example, we have given a units like 400 kilometer or 400 meter. If we divide it further into four parts, then it will go into 100 kilometers. So this is a unit. There again we are dividing it into division 100 kilometers. Then again we are dividing it into 10 parts, so it will be 10, each part will denote 10 kilometer, and again if we divide it into 10 parts, then each division will give the 1 kilometer. Okay, so this will be your division after dividing it into 10 parts. Then again this will be your subdivision. Okay, and this 400, when we divide into 4 parts, this will represent unit. Okay, so three consecutive relationship, unit, then again we are dividing it first division, then again we are dividing it second subdivision. Okay, so if we want to represent the relationships just like this, then we have to use the diagonal scale. Okay, so now let me tell you what what is the principle on which this diagonal scale works. Okay, so for that let us take an arbitrary length. Okay, this is any line which is, let us say, AB, and length of this line is arbitrary. And what is our motive? Our motive is that I have to divide this line into equal number of parts. For this example, let's say 10 equal parts. Okay, so first what I am doing, I am just drawing a perpendicular at point B, and this perpendicular, the length of this perpendicular can be controlled by the user. For example, if I want to divide it into 10 equal parts, so I will be using a length such that this length can easily divided, can easily कैन बी इजीली डिवाइडेड इनटू 10 इक्वल पार्ट्स। मुझे ऐसी लेंथ लेनी है जिसको मैं इजीली 10 इक्वल पार्ट्स में डिवाइड कर पाऊँ। फॉर एग्जांपल इसको मैं 10 सेंटीमीटर ले सकता हूँ, सॉरी दिस लेंथ आई कैन टेक 10 सेंटीमीटर सच दैट कि इसको मैं अगर 10 पार्ट में डिवाइड करूँ तो इंडिविजुअल डिवीजन क्या आएगा 1 सेंटीमीटर, जो आप इजीली मेजर करके यहाँ पे डिनोट कर सकते हो। ओके, सो लेट अस से 1, okay, this is your 9, 8, 7, 6, 5, 4, 3, 2, 1, and this point is, let us say, BC. Okay, so length of BC, in this case I have taken 10 centimeter. Why? Because of above reason. क्योंकि मुझे AB को 10 इक्वल पार्ट्स में डिवाइड करना था, तो BC मैंने लाइन ऐसी ड्रॉ करी जो 10 इक्वल पार्ट्स में इजीली डिवाइड हो जाए। Okay, now next step is join this A with this C. So here I have joined point A with point C. Now what I will do, जो भी हर डिवीजन से आपको AB के पैरेलल लाइंस ड्रॉ करनी है टू intersect at C, AC line. So from point 9, this is the line, again point 8, point 7, 6, 5, 4, 3, 2 and 1. Okay, and I am naming it 1 dash, 2 dash, 3 dash, 5 dash, 6 dash, 7 dash, 9 dash. Okay, now consider a first triangle ABC and any triangle. For example, let us say 7, 7 dash C. You can easily see these two triangles are similar triangle. Why? Because in these both of these triangle, one angle is 90 degree. See, okay, and second angle is equal for both. 7, 7 C, this angle is same. Similarly, ABC, this angle is same. Okay, so these two triangles are similar triangle. So with the help of properties of similar triangle, the ratio of the ratio of sides of these triangles should be equal. So using that property, I can write AB divided by BC should be equal to 7, 7 dash divided by 7C. From here, I can write 7, 7 dash is equal to 7C over BC into AB. Okay, now 7C divided by BC. BC means this distance. Sorry, let me draw it with the help of line. Straight line. This is the distance BC. Okay, and 7C is this distance. Okay, in our case BC is 10 centimeter. Okay, so if I want to find out the ratio 7C over BC, BC is 10 centimeter, and obviously since I have divided it into 10 equal parts, so 7C will be equal to 10 centimeter. Okay, so I can write this 0.7. Okay, so this 7, 7 dash will be equal to 0.7 of AB. Okay, this is one relationship if I am considering which 7, 7 dash C triangle. Similarly, if you are considering again triangle ABC and any other triangle, so by repeating the same step, you will get 1, 1 dash will be equal to 0.1 AB, 2, 2 dash is equal to 0.2 AB, 3, 3 dash is equal to 0.3 AB, dot dot 9, 9 dash is equal to 0.9 AB. Okay, or same you can write it 7 by 10 AB, or 1 by 10 AB, or 2 by 10 AB, here 3 by 10 AB, here 9 by 10 AB. So from these answers, what we can easily say that what we are doing, we have just divided this line into 10 equal parts. For example, this 1 dash length will give me the 1 by 10th part of AB. See this equation. Okay, again this 2 length, 2 dash, this will give me 2 by 10th part of AB. Okay, so that means if I am going from 1 dash to 2 dash, it is increasing just by 1 by 10th of AB. So this is 1 by 10th, or this is 1 by 10th. Similarly, 3 dash 1 by 3 by 10 of AB. So this is the principle with the help of which we are easily able to divide this line AB into 10 equal parts. Okay, so this is the basic principle on which diagonal scale works. Okay, so now let us take a question. With the help of that, you will get a better idea. Okay, in this question it is given that a map of 120 into 100 centimeter square represents an area of 3000 square kilometer. Okay, construct a diagonal scale to measure kilometer, hectometer and decameter. See all the three units consecutives. That's why we said that it represents the relationship between three consecutive units. Find its RF, indicates its scale, in this scale a distance of 5 kilometer, 4 decameter, 3 hectometer. Okay, so first of all we have to calculate RF. So RF is representative factor, and since the area is given, so we have to take the square root of the area. Okay, so what is the drawing area? That is 120 into 100 centimeter square. Again, actual area is 3000 kilometer square. So kilometer square, centimeter square will be 10 to the power 10 centimeter square. Okay, this will cancel out. From here this will go, from here this will go, 3 4 ja. Okay, when you will take under root, it will come 2 by 10 to the power 5, or in other words we can say 5 into 10 to the power 4. So this is your RF. Okay, now next we have to find out length of scale. Now length of scale is the multiplication of RF multiplied with L max. Since इस क्वेश्चन में आपको L max कहीं नहीं दिया है, but you have given a distance which you have to represent on the scale. जो स्केल पे लेंथ रिप्रेजेंट करनी है वो आपको दे रखी है. So obviously we have to take a distance which is larger than this, क्योंकि अगर इससे ज़्यादा L max की वैल्यू इससे ज़्यादा नहीं लेंगे तो आप इस डिस्टेंस को रिप्रेजेंट नहीं कर सकते. So assuming L max to be 6 kilometer. Okay, so R max RF is 1 by 5 into 10 to the power 4 multiply with 6 kilometer, so 10 to the power 5 centimeter. Again it will cancel out, it will come 12 centimeter. Okay, so what we have to do, we have to make a diagonal scale of 12 centimeter. Okay, so let me draw a diagonal scale first of all of 12 centimeter. Let us say this is 12 centimeter. Sorry. Okay, 12 centimeter, and this 12 centimeter is representing a length of 6 kilometer. Okay, now when we have to represent an individual kilometer, obviously we have to divide it into 6 part. Why? Because whole length is representing 6 kilometer. So for getting 1 kilometer length, or individual kilometer length, we have to divide it into 6 equal parts. So sorry, scale. Okay, so here what I have done, because of space constraint, I have drawn first box, a bigger box, because यहाँ पर हम लोगों को बहुत ज़्यादा बाकी फर्दर डिवाइड करना है 10 पार्ट्स में, देन फिर फर्दर डिवाइड करना है। उसको क्लियरिटी के लिए मैंने इस बॉक्स को बड़ा बनाया है, बाकी सारे बॉक्स छोटे बनाए हैं। ओके, बट कीप दैट इन माइंड, ऑल ऑफ दीज बॉक्सेस और ऑल ऑफ दीज आर इक्वल स्पेसेस, इक्वली डिवाइड है ये। सो जितनी डिस्टेंस ये होगी उतनी ही डिस्टेंस ये होगी। मतलब if you are dividing 12 centimeter into 6 parts, so each division will be 2 centimeter. So this will be 2 centimeter, this will be 2 centimeter, this will be 2 centimeter. So every division will be 2 centimeter long. Okay, so keep that in mind. जहाँ पर अगर आपको लग रहा है कि इक्वली डिवाइड इक्वल डिवाइड नहीं है, दैट इज ओनली बिकॉज आई वांट टू रिप्रेजेंट द स्केल क्लियरली। मैं क्लियरली रिप्रेजेंट करना चाह रहा हूँ, शो करना चाह रहा हूँ, दैट्स व्हाई। ओके, नाउ दिस विल बी 0. This is 1 kilometer, 2, 3, 4 and 5. Okay, now each division is representing a 1 kilometer. Okay, now we want to again see, we have to represent hectometers. So to represent a hectometer, we have to again divide a kilometer into 10 parts. Okay, then only we can represent a single hectometer. Okay, so again I will divide it into 10 parts. Let me check कितने ड्रॉ कर लिए. This will be your 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. इसको मिटा के दोबारा बनाते हैं. It will deflected. Okay, this is 0.9 and again this is 1. Okay, हमने क्या किया, इस पार्ट को मैंने फिर से फर्दर 10 पार्ट्स में डिवाइड किया. नाउ ईच डिवीजन, जो स्मॉलर डिवीजन आया, दिस विल बी रिप्रेजेंटिंग व्हाट, 0.1 किलोमीटर. ओके, सो एक हेक्टोमीटर आपका ये डिवीजन रिप्रेजेंट कर रहा है. ओके, आई विल remove it because again we have to further divide it. Now we have to show a individual decameter also in this scale. Okay, so again we have to divide this much distance further into 10 parts, then only we can change this one hectometer distance into decameter. Okay, for that what we'll do, we will divide this length into 10 equal parts. Sorry, 3, 4, 5, 6, 9. Okay, so this I have divided into 10 equal parts. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now last step is diagonal scale. So I have to join these points diagonally. Let me draw with some other color because the visibility will be better. So now we have to draw it with diagonal lines. to use the principle of diagonal scale, which I just explained last page. Okay, so this is the diagonal scale again. Now each division will represent what? 0.01 किलोमीटर, क्योंकि हमने 0.1 किलोमीटर को फिर से फर्दर 10 पार्ट्स में डिवाइड किया है. ओके, सो दिस विल बी योर 0.01, 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, 0.08, 0.09 and 0.1. Okay, that's it. Now we have drawn the diagonal scale, and last step is we have to represent a distance: 5 kilometer, 4 decameter, 3 hectometer. Okay, that means this is 5.34 kilometer. Okay, or in other words you can say 5 kilometer plus 0.3 kilometer plus 0.04 kilometer. Okay, so see, from here 0, 1, 2, 3, 4, 5. So this much distance will represent 5 kilometer. Okay, from here to here, this is 5 kilometer. Okay, 5 kilometer. Again, what was 0.3 kilometer? Okay, so 0.1 is this, 0.2 is this, 0.3 is this. So this must will be 0.3. Last 0.4, 0.04. So for 0.04, what we'll do? We will go towards upper side. Okay, see, this is 0.3. Up now 0.3. I have to move up to 4. So 0.31, 0.32, 0.33, 0.34. Okay, so this is the point of 0.34. So up to this length. Now this whole length, let me erase it, then again I will draw from here to here. This whole length is representing 0.34 kilometer. Okay, so this length is now 5.34 kilometer. Okay, so this is the way to draw any diagonal scale. Here you can easily see कैसे हम लोगों ने तीन consecutive units के relationship को represent किया है. Okay, now let us consider one more question of the diagonal scale. So in this scale, what is given, that RF is 1 by 32, and now it is showing yards, feet and inches, and to measure up to 4 yards. So before going into this scale or drawing this scale, we should be very clear about the unit conversion of these units. So 1 yard is equal to 3 feet. Okay, and 1 foot is equal to 12 inches. Okay, so these 3 units are also consecutive units. Okay, now we will proceed again. RF is given, that is 1 by 32. L max is given in the question, so you have to find out length of scale. So length of scale will be your RF into L max, that is 4 yards. Then you will convert yards into feet, so that will be 3 feet. Now again you will convert feet into inches, so that will be 12. Now I don't need to convert it into centimeter. Why? Because I have the scale through which I can draw any length whose units is given in inches. Okay, so it will come okay. sorry, wait a minute, 12 divided by 32, so it will come 4.5 inches. Okay, so what we have to do, we have to just draw a scale of length 4.5. okay, so that we'll draw in next page. Again, I will draw a scale of 4.5 inches. Okay, this is the length of 4.5 inches. Okay, and this 4.5 inch length is representing what? 4 yards. Okay, now again go back to the question, what we have to represent. We have to represent single yard, feet and inches. Okay, so this whole length is representing 4 yards. To read a single yard, we have to divide it into 4 parts. Okay, so let me divide it into 4 parts. 4. Now this will be your 0. This is 1 yard, 2 yard, 3 yard. Okay, now again what you have to do, we have to read a single foot. Okay, from unit conversion we just saw that 1 yard is represented by 3 feet. So if I am dividing the distance which is representing 1 yard into 3 parts, so that will represent what? 3 feet, sorry, individual feet. So I am just dividing this into 3 parts. Okay, so each division will represent what? 3 feet. Now what I have to write here, I have divided this 1 yard by in 3 parts. So 1 by 3, 2 by 3 and 1. Okay, so each this smaller division is representing 1 foot. Now again you want to go from foot to inches. So this conversion, 1 foot is equal to 12 inches. So now what we have to do, now we have to divide this 1 foot into 12 parts to represent 12 inches. Okay, so let us say again I have to divide this line into 12 parts. Okay, sorry. Okay, this I have divided into 12 parts. Again, diagonal scale, join this line to this, this line to this line to this. Okay, now see, this is 1 by 3. Okay, 1 by 3 yard, and again you are dividing this 1 by 3 yard to 12 equal parts, so this will come 1 by 36. So this will be 1 by 36, and again 2 by 36, 3 by 36, and similarly here it will come what? 1 by 3. You can say 12 by 36. Okay, here it will be 11 by 36, 10 by 36, 9 by 36, and so on, that you can easily write. Okay, so this is the diagonal scale which we have to draw. So this is the complete diagonal scale. Now let us see, there is no distance which has been given to represent it. Okay, so let us consider we want to represent 4 yards, sorry, 4 is the full limit, so we want to represent 3 yards, 2 feet, 3 inches. Okay, so again 3 yards from 0 to 1 to 2 to 3, so this distance is 3 yard. 2 feet, this is 1 by 3, so 1 feet. This is 2 by 3, 2 feet. Again 3 inches, so 1, 2, 3. So this, sorry, Now this length will represent what? 3 yards, 2 feet and 3 inches. Okay, so this is the way how we have to draw the diagonal scale. So keep that in mind. In case of diagonal scale, we are able to represent 3 units. Okay, so it is giving the more precise reading as compared to the plane scale. In plane scale, we are just able to represent the relationship between 2 consecutive units. On the other hand, in case of diagonal scale, we are representing the relationship between 3 consecutive units. Okay, so this is the overall idea of diagonal scale. Okay, so thank you.